Hello, Professor Faltings. It's very exciting to meet you and congratulations on winning the Abel Prize 2026.
Thank you very much.
I wanted to ask you, what was it about mathematics that first excited you, that first made you want to study mathematics?
I think it was that there's a clear distinction between true and false. I mean, you either have proof or not. Well, for example, in school in literature, there were various ways to think about it and different interpretation and so on. And I didn't like that too much.
You were very young when you proved the Mordell conjecture. I think everyone was surprised. Were you surprised?
Well, I was surprised, but maybe Abel was still alive in my age, but he also died, yeah. Well, he died, yeah.
Did you feel that you had some urgency, that you should get some work done really quickly?
No, I was, in the beginning of my career, I wanted to get tenure so that I could live off my work. And I got this, and then I suddenly got very lucky with the Mordell conjecture. And since then, I'm sort of traveling first class in mathematics.
What kind of impact does it have when you get such an amazing result so young? Because you were not even 30. Were you 30?
No, when I proved it, I was 83, I was 28.
People were surprised by the method you used to solve it. Did you set out to prove it, or were you looking for something else?
Well, there was a friend of my advisor, Luc Spiro, who lived in Paris, and he had ideas about Mordell. And I thought they sounded interesting, and I thought, well, I can work on it, probably I won't prove it, but I will get something interesting out of it.
But you proved it by quite an unusual method, didn't you? Can you explain briefly why people were so surprised by the method that you took?
The things which were natural maybe from Spiro's point of view, and I was sort of lucky that the people in Paris didn't quite take him serious, and so I had not so much competition. So I did things which were natural from its point of view, and I suddenly was successful.
A lot of your great work has been in number theory. To a non-mathematician, that sounds like, but isn't all mathematics numbers? Can you explain, in a way someone who hasn't done mathematics in school would understand, what is number theory and why is it so interesting for mathematicians?
Well, number theory, it starts with the integers 1, 2, 3. We usually can count so far, and then you try to do things to solve equations in these, and it's sort of an elementary thing, but you get interesting questions, and for some people like me, it's interesting. I guess for others, it's not so interesting.
But the work you're doing is much more mysterious, isn't it? Numbers behaving in mysterious ways. What were the puzzles that made you think, well, this is interesting?
Well, mathematics has been done since centuries, and naturally things evolved, and sort of things which we do in school maybe are, 300 years old or so. And naturally the theory has advanced. We are far away from the elementary things. Well, we had this old field of number theory, and it sort of has also certain romantic appeal, but there are of course other fields. You want to compute orbits of space vehicles and so on.
You've been at the Max Planck Institute for a very long time. What does that enable you to do? What's special about being there?
Well, being there is that you have a few obligations and besides doing research. So I could do this for a long time. Well, I did some teaching at the university here, because we have a good relation to the university, and also teaching is good for you because you have to talk with ordinary people and have to learn how they think and to explain things. So teaching without keep you down to earth.
Oh, that's interesting. What advice, if there was a young mathematician starting now, I mean, maybe looking for a PhD subject even, what would you suggest to them? What advice would you give?
I think for a young guy, well, my advice has always been not to look what might make you famous. Well, let's say get the Abel Prize, but to do things which you like. I mean, to choose a field which you like and find interesting and then work on this.
So finally, you say you're left with the problems you couldn't solve. So what are the problems you're still working on?
Degree of Weyl parametrization for elliptic curves. And well, I find it very interesting, but I don't get ahead. So that's my, well, as I said, you are left with the problems which you can't solve.
Is it possible to solve?
Well, I don't think it's impossible, but it gives me a pleasure to work on this.
Thank you very much, Prof.Falting, and congratulations again on winning the Abel Prize 2026.
Thank you very much.
Thank you.